Hello Math 10 and welcome to Chapter 3 and Lesson 2. Now you should have these notes here from your package that you've been given for Chapter 3. So we're looking at Lesson 2 and today we're looking at perfect squares, perfect cubes and their roots. And we're going to use a couple of different ways. We're going to look at finding square roots and cubic roots using factoring, and then we're going to also look at a method using estimation. So this is our first example here. Now you can make notes on the left hand column. You can be in your meaningful notes, you can jot down some notes with this if you wanted to. Now before we get started here, let's talk about square roots. Now you've been using square roots for quite a while now, at least back to grade 7. And today we want to avoid using a calculator, but let's talk about square roots for a moment. Now, if we look at a really easy number, square root of 9, well, most of you will recognize that that's equal to 3. Now, why is that? Well, this is equivalent to saying, and that equal sign with 2 arrows on the end means equivalent. Really, it's the same thing as saying that 3 to the power of 2 is equal to 9. So both of those statements are equivalent, aren't they? So one is a square root statement and one is a square statement. Now, if I wrote down now the square root of 3 to the power of 2, what would you say that was? Well, of course, that's just the same as the square root of 9, which is equal to 3. Now that's interesting because what we notice here is that we've got two operations going on here. We've got squaring, which is 3 times 3, and then the other operation we've got, of course, is taking the square root. Now the interesting thing about the squaring as an operation and taking the square root is that these are what we call inverse operations. Now, we've been dealing with inverse operations for a long time. We know that if we've got addition, subtraction is the inversing operation of addition. And what's the other one? Well, of course, we have multiplication and we have division. And so here we have squaring as one operation. The operation which reverses squaring, of course, is the square root. All right. So keeping that in mind here, what we can write is, if you've got any old number, let's say it's a, and it's squared. If you take the square root of a squared, of course, that's just equal to a itself. Now, we're going to use that idea here and look at how we can go through and use factors and prime factors in particular to go through and find the square root of 576. Now we do not want to go through here. It would kind of be cheating to go through and use our calculator in this particular case. So what we're going to do here is we're going to take 576 and we're going to go through and we're going to write out all its prime factors. Now you can see that it's an even number, so we'll start by dividing by 2. So that divided by 2, and using a bit of mental math here, what's that equal to? That's equal to 288. So we're going to keep on going through here, 288, and I'm just going to, that's equal to a 144. 144 divided by 2. We've got 72, and we keep on going. Here gets a little bit tedious, and that's 36. 36, and that's equal to 18. Goodness me, we can keep on going here, can't we? 18 divided by 2, and that's equal to 9. Oh, finally, we've got an odd number. 9, well, yep, that divides by 3, and that's equal to 3. And finally, 3 divided by 3 is equal to 1. Now, what we've got here is, look at this. These are all our prime factors. Now, let's take them off in groups of 2. We've got a group of 2 3s. We've got a group of 2 2s there, another group of 2 2s, and another group of 2 2s. So we could write 576 is equal to 2 to the power of 2 for the first pair of 2's times 2 to the power of 2 again, and then we've got 2 to the power of 2 again, and then finally we've got 3 to the power of 2. Now, the square root of 576, we could go through square root of 2 to the power of 2, 2 to the power of 2 again, square root of 2 to the power of 2, square root of 3 to the power of 2. Now, what's that equal to? Well, look at this. As we just saw up above previously, the square root of 2 to the power of 2 is just 2, isn't it? Again, square root of 2 to the power of 2 is 2. 2 for this one here, and finally square root of 3 to the power of 2 is 3. And so we have the square root of 576 is equal to the product of all of these. 2 times 2 is 4, times 2 is 8, times 3 rather is 24. So there it is. Using prime factors and using the fact that the square root of a squared is just equal to a, we can come up with a value for the square root of 576, which is 24. Now, hey, while we're at it, 24 to the power of 2, of course, is equal to 576. Now, why didn't we just go through and use our calculator? Well, this is all about factors. It's understanding how numbers work, and I think that's kind of a nifty way to go through and do it. Now, the success of this method, all right, we needed 576 had to be a perfect square to start with before we could go through and use this particular method. So the next one we're going to look at here is we're going to look at the cube root of 2744. Now, using symbols, we would write it like this, 2744. And you'll notice on your scientific calculator, you've got a button that does that. But we don't really want to use that button just yet. So let's talk about cubes. All right. We know that 2 to the power of 2 is equal to 4. The square root of 4, or 2 to the power of 2, is equal to 2, isn't it? What if we took 2 to the power of 3? Well, that's 2 times 2 times 2, which is equal to 8. Okay, and we can write that the cubic root of 8, that's just equal to 2. So what we notice here is, another way to think about this is the cubic root of 2 to the power of 3, which is what 8 is, that's just equal to 2. So once again, as we mentioned before, squaring and square root are inverse operations, and here we have the same thing going on. If we raise something to the power of 3, which we call that cubing, that's one operation. Taking the cubic root is the inverse of that operation. So the cubic root of 2 to the power of 3, it's so they kind of, well, you can think of it as they kind of cancel or they undo each other. So what we can say is if you've got a number a and you raise a to the power of 3, and then if you were to go through and take the cubic root of a, the cubic root undoes or reverses the cubing, and so we're left with a. So we're going to go through and we're going to use that principle here to find, using factors, using prime factors, we're going to find the cubic root of this number here. Now, you can go through and you can put this in your meaningful notes, and then you're going to try the example. So let's start off here. So we'll start off with 2744, and we're going to go through and we're going to do the prime factors. So we're going to do it as a list. So we'll start off by dividing by 2. And this is great for mental math. And so that's equal to 1372. So 1372, we can divide by 2 again, and that's equal to 686. So 686, and that's equal to 343. Okay, we've got an odd number. Now, you might think 343. If we try to divide it by 3, it's not going to work. Okay, so 343 does not have a factor of 3. Clearly 4 is not going to work, okay, because it's not even. 5 is not going to work. If you try 6, it's not going to work because 3 doesn't work. But I find that you can divide it by 7. So that's our next biggest prime, and that's equal to 49. 49, we can divide by 7 again. That's equal to 7. And finally, we get 7 divided by 7, and that's equal to 1. So here are our prime factors. We've got a group of 3 2s and a group of 3 7s. So we can write here that 2, 7, 4, 4 is equal to 2 to the power of 3 from those ones there, and it's times 7 to the power of 3. So the cubic root of 2744 will be the cubic root of 2 to the power of 3 times the cubic root of 7 to the power of 3. And so we end up with, now look at this, we've got the cubic root of a cube happening twice, so that's just equal to 2. And then we've got the cubic root of 7 to the power of 3, which is equal to 7. And so 2 times 7 is equal to 14. Now, you can check it out. 14 to the power of 3, okay, which is 14 times 14 times 14. Now, check it out. You'll find that indeed it's equal to 2,744. For this next example, we're going to use estimation. On one of your pages in lesson 3.2, you've got a couple of number lines like this. So I've got all the numbers on the first number line here. I've got all the numbers going from 0 to 20. Let's just call that x. Okay, so all the numbers here are x's. Now underneath, what I'd like you to do is let's go through and complete this. And so what we're going to do is we're going to take x and we're going to square it. Now, you'll see how it's done here. So 0 squared is 0. 1 squared is 1. So right underneath on our second number line, we're going to put all the squares of the integers above. So we've got 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16. Keep on going here, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, having to write fairly small here. What's 16 to the power of 2? 256, 289 for 17 squared, 18 squared of course, 324, and 19 squared is going to be 361, and finally 20 squared is equal to 400. Okay. Now, we're asked to go through and find the square root of 110. Now, on our number line here, you can see 110 is somewhere between 100 and 121. Now, it's roughly halfway in between, I would say. So 110, so roughly round about there like that. Now, so its square root, the square root of 110 is going to be somewhere between 10 squared, which is 100, and 11 squared, which is 121. So you might estimate here the square root of 110 may be approximately equal to about 10.4, 10.5, somewhere in there. So we've made an estimation there. Now, we can check it out on our calculator to see what it is precisely, to see how good our estimation was. So I've got the square root of 110, and that's equal to 10.488. All right, so it's closest to around about 10.5. So using this method here, okay, with having one number line with our whole numbers and then the squares underneath, we can get estimations for where a square root approximately is going to be. And here we are for the last question for lesson 3.2. So what we want to do here is a cube. We're told some information. We've got a cube. Here's a cube. A cube is just a block, something like a die. Has a volume of 216 cubic inches. And we're asked for what is the surface area of a cube. Well, we've got a couple of things we need to do. So let's go back and just review something about volume. Back in grade 8 and grade 9, in math then, you looked at volumes of rectangular prisms. All right, so this is an example. A cube is an example of a rectangular prism. It's like a box. Well, volume, if you remember, was just BA, which is the base area, times the height, wasn't it? Now, the interesting thing about a cube is that all the sides are equal in length. So on the 3 dimensions there, I can go through and label S for side, and they all happen to be the same. So we can say that a volume of a cube is going to be the base squared, okay, which is a square, times S, and of course there's S to the power of 3. And that also explains why, okay, S to the power of 3 is S cubed, and of course from S cubed, of course, that's why we got a cube there, isn't it? So now let's think about, we're talking about surface area here. Now, I think if you remember back, what I've got down here is I've got the net that we could fold up to make a cube. And of course, what does a cube has? A cube has 1, 2, 3, 4, 5, 6 sides like that, and they're all squares. Each square, of course, is S like that, isn't it? It's S squared. So what do we need to do first of all here? Well, we haven't got the side length here, but we do have this. We can say that S cubed, which is our volume, is equal to 216. Now, in this particular example, rather than go through, take all the time out to go through and find out what this is by factoring, we'll simply use our calculators here, or maybe you've got this on a list already. So this would mean if we want to go from S cubed to S, we have to go through and take the cubic root of 216. Now, if you put that in your calculator, or if you've got a table with it on, that's equal to 6, and the units are going to be inches, aren't they? Now, that's S. Now, each of these squares that make up the surface area of our cube, they're going to have a surface area which is S squared. Now, because there are 6 sides, we can say here SA for surface area is 6 times each little square side, which is 6 times 6 squared. Okay, and this is kind of interesting because 6 times 6 squared is 6 times 36, and 6 times 36, of course, is our number 216. And so this is going to be square inches. Now, that was a bit of a fluke, because what we found here is we found that the volume was 216, and of course, that's inches cubed, and coincidentally, all right, numerically, it's the same as our surface area. But that was just a little bit of a fluke. And part of the reason for that is with the cubic root, of course, of 216 was equal to 6. And of course, coupled with the fact that there are 6 sides, we just got 6 times 36, which happens to be the same thing. Okay, now you have some examples there that you can do and try those, and you can make some notes in your meaningful notes.